Okay, so welcome back, and in this video here we have a sequence, and I just realized I didn't take my jacket off. So we have this sequence here, and in the sequence we have a polynomial, a rational expression, and this may look familiar because you may have done these, I'm sure you have, with functions, right? When you're taking the limit of a polynomial function, a rational function. So guess what? Well, it's hard to see what's going on. Now again, if you remember the rules for functions, right, if this was f of x, and we had a polynomial of degree 4 and a polynomial of degree 4 on the top and the bottom, we know that the limit of this thing is going to go to the ratio of the leading coefficients, right, which is going to be 3 and negative 4. So this thing is going to have a limit, and it's going to exist at negative 3/4. But let's use the limit laws and confirm that, okay? So now, what I'm going to do is, I'm going to divide both the top and the bottom by n to the 4th, okay? So what I'm going to do is, I'm going to rearrange, well not rearrange, not the right term. I'm going to change the way this looks to better see where this thing is going, okay? Because the way it looks right now, it's hard to see where this thing is going, okay? Unless you reason through it, okay? Again, you could look at the behavior, right, as n gets really large. You can look at n behavior. Remember n behavior of a function. That's part of why we know it's going to go to the ratios. But with all that set aside, let's rewrite this by factoring out n to the 4th. Or in other words, dividing the top and the bottom by n to the 4th. And so we get 3 minus 7 over n squared plus 5 over n to the 4th, 6 over n to the 4th minus 4. Now you can better see what's going on here. So remember, we know that 1 over n to the kth power converges to 0 for all positive integers k. Okay? So let's rewrite this to see this even better. So now, we see when we take the limit of this thing, this is going to go to 0, all of these are going to go to 0, and we're going to be left with negative 3/4. So the limit as n approaches 0 of 3 minus 1 over n squared. Also, as n gets really, really large, we know that 7 over something large is getting smaller. So we can also see that this is going to go to 0. As n goes to infinity, this is going to 0, and this whole thing is going to 0. So it's not, you should see this. Okay, so now, this is going to equal the limit, so I'm going to do the limit as n goes to infinity of 3 minus 7 times 1 over n squared plus 5 times 1 over n to the 4th over the limit as n approaches infinity of 6 times 1 over n to the 4th minus 4. And now I can use the limit laws across the adding and subtracting. So this is going to equal the limit as n approaches infinity of 3 minus 7 times the limit as n approaches infinity of 1 over n squared plus 5 times the limit as n approaches infinity of 1 over n to the 4th. And then similarly on the bottom we have 6 times the limit as n approaches infinity of 1 over n to the 4th minus the limit as n approaches infinity of 4. Okay, well, what does this give us? This gives us 3 minus 7 times 0 plus 5 times 0 over 6 times 0 minus 4. And so we get exactly what I said we were going to get, and it's negative 3/4. So this does converge, and it converges to negative 3/4. Have a great day.